Hi friends, today we are in our sixth module of risk conscious operations management for complex engineering system, and today's topic is probabilistic security risk assessment, and of course in this module the first presentation will be introduction. Okay, I am Professor Prabhakar V. Vardhe, and I had my 35 years I spent at Bhabha Atomic Research Center, and essentially plant operations and safety was the subject that I was working in, and I had special interest in probabilistic safety assessment of complex engineering system and of course nuclear power plants. And I am also guest faculty at University of Luleå University of Technology, and senior professor Homi Bhabha National Institute. So let us start the our talk. Okay, there is a disclaimer because we are discussing topic which is not sensitive, but it requires some sort of academics, model building and all that is required. This lecture is based on research and development that has been carried out and which have potential for application of a very well established methodology called probabilistic safety assessment to security aspects. And of course for cyber physical system also, the purpose is to present the state of the art education and whatever R&D insight that you have obtained, and enhance the awareness about the security risk, because in present context, apart from safety, this has become one of the major concern in industry, as well as if you see generally world over that ecosystem, because physical aspect as well as cyber security aspect, they have become very important. Lecture has been prepared based on the information available in either our R&D insight or it is available in the open domain like references. Okay, so attempt has been made not to give any specific information or to discuss anything which is related to any specific plant or specific organization. And with this disclaimer, I introduce the outline of this presentation. There are 5 presentations in this module, that is probabilistic security risk assessment. First, I will introduce the topic and try to emphasize the importance of this subject, and then the first item that comes in the security risk assessment is threat assessment, and this consumes a lot of energy in terms of gathering data and trying to find out the relevant threat, and then finally working out a design basis threat. Of course, the design basis threat, this philosophy has been borrowed from the deterministic philosophy, design basis accident. So the way it happened in probabilistic risk assessment or in present even deterministic methods, apart from DBA takes maximum resource, but other events are also explored to ensure that the plant provisions amply demonstrate the safety and security and whatever protection have been provided. So next topic comes is physical protection system. In general language we call vulnerability, and if I have to tell otherwise around, I will say the plant physical protection, and if there is a cyber concern, then these two things together they will make it resilient, plant resilient in terms of security threat. Okay, and that's why once we say resilient, opposite of it is vulnerability, which is discussed more in the open domain. Okay, then probabilistic security assessment, that I will be hinting on a methodology, whatever essential features that I will be discussing, and at the end I will discuss the cyber physical systems. Okay, and there I will be touching, because this is a very elaborate and exhaustive topic, I will be rather discussing what is the relevance of PSA into cyber physical system, and what are the core topics that need to be explored in another detail when we talk about the complex engineering systems. Now, when we talk about security, now there is a good appreciation, whether at national level, international level, that safety and security, they are like two sides of coin, and both need to be addressed to have a holistic assessment of plant safety and security. Okay. And of course, there will be some overlap also, and that need to be addressed. But the good point is, while doing safety assessment, we come across a very special area where we need security assessment also. So, if these two aspects are analyzed using a similar methodology, like for most of the complex engineering system process, aviation, nuclear, and all, we have a probabilistic risk assessment along with the deterministic methods. So, if we have security also analyzed, like defense in depth, and then finally following the strength of the different provisions, and so it will become easier for us to have a holistic view of plant's strength against safety and security threats. Okay. Safety is okay. So, if these two terms combine, if I have to talk, I have to say safety risk and security risk. So, PSA does probabilistic safety assessment does safety risk, and probabilistic security assessment does security risk. And then security assessment, it deals, there is a different threat connotation what we have for security, because safety is traditionally known gets adversely affected by random failure. So, random failure or probability of random failure is at the core of complete investigation. Okay. And that is how we try to see how safe is our plant against the random failures. But security is a different ball game. Here the intended causes or deliberate causes which harm the plant due to internal or external elements, or due to some malice and sabotage and this kind. So, and we see nowadays, in terms of our computer safety and all that, we see that repeatedly we are on day-to-day basis we are facing this problem of virus attack and many other issues. So, now if I come to this present trend in design operation is to have an integrated assessment of safety and security. And the good thing is, all the international guide or even national guides, they address these issues, especially regulatory guide, safety and security together, which makes the job of the analyst much easier actually. Okay. Now, why probabilistic security risk assessment? Okay. So far present methods are there, they are doing a good job, no doubt on that. But then when we talk about a systematic documentable approach, wherein the first thing is the uncertainty. Okay. Uncertainty should be captured and are managed such that the sensitivity to the final results is known, which component, which uncertain component is having more impact factor or less impact factor. So, that way the management part becomes easier. And compared to probabilistic safety assessment, security assessment, there are larger uncertainties. Why? Because the phenomena itself is highly unpredictable, whether it is a time domain or condition domain, whatever, or societal domain. So, it is highly unpredictable. So, and then second thing is data. So, most of the time in security risk assessment, we depend on the subjective data, that is expert judgment and this expert judgment or some limited test have been done on certain equipment, and then we derive the parameter. Okay. So, these are, but then one good thing is the way probabilistic safety assessment methods have matured, less effort will be required to mature the probabilistic security risk assessment. This was one of the R&D insight that we have on this subject, and the lecture encourages the way we do in safety, the risk informed. Risk is a common component to safety and security. So, risk informed or risk based tools and methods should be developed so that our resources can be utilized properly. And now another reason why we are having more emphasis on security assessment is security costs very high. If we look at the societal incidents in last 20 years, the cost is exorbitant. Okay. Of course, unlike other systems, for every system it may not be the case, but when it happens at a higher scale, the cost becomes a prohibitive thing even for a particular domain itself. Now, we are discussing probabilistic security risk assessment. Let us try to have, though in my research I could not find any single definition which is all acceptable. So, for the purpose of this I did little search which I will show you, but in line with probabilistic safety assessment, the definition here we are formulating, and for the purpose of this lecture, an analytical approach that postulates likelihood of various threat scenarios initiated by intended sabotage, attack and effectiveness of resilience and series of physical protection system, capability of provisions. Provisions include many things, resources, manpower and all. So, everything become part of the physical protection system towards evaluating risk of harm or damage to the facility. And of course, the consequences should not be there in the public domain. So, this is the definition. The strength of probabilistic security risk assessment is that we get to know the vulnerability of strength and vulnerability of the physical protection system, and even if it is a cyber physical system, we get to know the vulnerability. We can work upon it actually, and then comprehensive PSRA deal with the modeling of physical as well as cyber security system. So, that's why, just to give the holistic treatment, the last lecture has been on cyber security in this. And now let us see some general point. Objective of security provisions: yes, prevention of threat. If any threat is there, prevention and protection of the facility or organization or public, and if it happens partly or fully, the threat becomes successful, then management, so that the consequences in public domain or property and environment can be reduced to the acceptable level. Okay. So, once we talk about PSRA, now I will be using abbreviation of probabilistic security risk assessment, PSRA. Okay. So, let us say we have a plant, it could be an organization also. So, I am referring here a plant, okay, and this plant we have shown here. Now, when we talk about the security, we have to really characterize the asset. This could be in terms of level of hazard that is there. Number two, what are the plant provisions, what are the pathways, what are the defenses, and a plant culture. So, this characterization is very important for any asset for which we are carrying out the security risk assessment. Then we get to know the safety and security requirement. What are the requirement for safety and security? Okay, because as I told you, now both these topics are being dealt together. Of course, we will be limiting ourselves in this module on the security aspects only. So, that is why the plant physical protections, like we say in plant normal safety systems, here it is plant physical protection system. Now, we have to understand the provision in the plant or system, and here we are referring to plant physical protection system. Now again, if we come back to this node that is plant, once you have a plant, there will be postulated threats, and then postulated threats will be a list of threats. Of course, design basis threat gets very focused attention, but other threats, because in security the scenario is evolving very fast. So it's not so if the design basis threat will does a job for 50%, for remaining 50% there will be many new scenarios which will be coming in. So we will have a list of postulated threat scenarios, including its characterization and if possible the quantification also. So we have a physical protection system, we have a threat, and these two together will give us a vulnerability assessment. Okay. So that is effectiveness of the physical protection system will give us the vulnerability, or otherwise also you can say strength of the the effectiveness of physical protection system will give resilience to the plant also. So in security risk assessment, it is the vulnerability, this term is used. So just we are trying to club this concept, and then risk scenario. Whatever risk scenarios are there, it is used for risk management and reducing or increasing the effectiveness of the physical protection system and reducing the chances of threat sequences. So that way in feedback loop we work on reducing the or increasing the security of the system so that events can be reduced. And of course, if the like plant physical system, we have mitigation measures also. So that also affects the vulnerability, and that reflects in reduction in intensity of risk scenario, and that's how the cycle is completed. So now let us try to understand what is the threat we have understood. Anything threat or any event which can destabilize our plant, and if it is handled properly, the consequences are lesser. But now systems which are coming in between to reduce or eliminate the intensity of threat is physical protection system or provisions. So the major elements of PPS are or physical plant protection systems are to protect and check against the unauthorized and unlawful entry of the people, because persons are more important. Like we said in our PSA also, human factor is very important. So here also unlawful entry material that has potential for physical harm, protecting against the theft and other things is the objective. So to ensure locating and neutralizing the neutralizing provision. So here, even if the threat becomes a reality, we have to see that locate the threat root causes and neutralize them. So since this particular philosophy has been derived from nuclear, so the reference is there nuclear, but it could be applied to any field actually. Then protect nuclear facility against so these are all IAEA guidelines which are there in their guides to mitigate or minimize damage sabotage, mitigation or minimizing of radiological consequences. So when we talk about any aspect for implementation, we have to consider a system, and here a lot of advancement has been seen in nuclear area. So there are IAEA, International Atomic Energy guides are there, they are in open domain, and for this lecture they have been referred actually. Now what are the major steps? We have seen sort of which are the essential elements of this, but what are the steps that are there? So what is done is, first is define the objective function and formulate a design basis threat also, because around this only other activities will be, rather design basis threat will standardize our formality, and then it can be applied to any other event also. Study of design and operation features, and along with this lot of data collection, feature collection, drawings and all have to be collected, areas have to be collected, boundaries have to be identified, nature of boundary has to be identified, the condition of the boundaries and defenses have to be identified, Then identify provision of physical cyber protection. Now there is a physical aspect and then cyber security aspect. So identify the provision of those things and what needs to be protected, to be identified, and then deterministic and probabilistic modeling assessment has to be done. Deterministic means essentially defense in depth provision, ensure the defense in depth provisions, and then various core element of deterministic depth, and how the probabilistic element, we are using these two in a holistic manner to submit it to the regulator, so that there will be independent review and then recommendation will be generated, and then we have got a broad methodology for probabilistic security risk assessment. There are definition in the codes and guides and all, they are all given here. Just a physical protection system is like simple language. We have to understand what is safety for safety system for in the plant. We have for security physical protection system and cyber security systems. Here we include the systems, procedure, person, equipment, which ensure or protect the security of the plant. Overall system effectiveness. How you ensure that the system is effectiveness is good. So one way is to perform probabilistic calculation of its performance over the years, so that we'll know how many times the systems have failed, or how many times the humans were not able to detect, delay, because in security assessment also there is something called drills that has to be carried out to ensure that the provisions are effective. That is a deterministic approach. But then from there, lot of data testing and all, lot of data is collected. So those data should be analyzed for ensuring the system effectiveness. Neutralization means the adversary's capability has been reduced or eliminated, and it is demonstrated that the plant is safe actually. And then we have protective force timeline. I mean, security assessment, security responsibility lies with the routine staff of the system, but then there are special forces which are kept reserved. So whether at the time detection and availability of these forces, what is the gap and what is the timeline, that has to be understood for ensuring the effective security measures. Then overall system effectiveness, it is, I think, second time it is being coming over here. We have, and design basis threat. The way we have design basis accident, here we have design basis threat, a scenario with maximum credible potential, and for which we have provision in the plant and the safety has been demonstrated. Okay, but in security assessment, story doesn't end there. As I mentioned initially, we have to take many other events which might become possibility. They might show very low likelihood, but then if you leave the term likelihood, then that has to be analyzed, because conditional probability, if we take 1 for most of the events, then we are sure that we will get a very holistic answer what are the type of protection system. Of course, the reference will change because quantification brings something to one reference level, and then conditional probability will bring it to the another reference level, but then the insight, safety risk insight will be the same. And then critical interrupted point, what should be our provision, so that the capability of response, which response is sufficient to neutralize the threat. So this is what is called critical interruption point. It is in location, spatial domain. Critical detection time. And now security risk assessment, we have discussed the definition. Here we are just trying to elaborate, identify the physical performance of physical protection system, and together vulnerability assessment of the plant, and then based on that the requirements that we develop actually. So this is in lecture 1. We discuss introduction, identified safety and security and their overlap also. While doing safety analysis, we might come across certain basic element or intermediate element which are relevant to security also. So from there, one more dimension will come, and at the same time, when we do security event analysis, one safety point will come out, and so this overlap is called safety. Interaction is called safety and security overlap, and they are very important. Why PSRA? We have discussed major element of security assessment, and then definition in risk assessment and safety critical facilities. These are the references for your use. You can refer these documents.